Hello again, everyone. This is Mr. V. Hill. Today we're going to be talking about parallel and perpendicular lines. Starting off with parallel lines, we're just going to look at a quick little example. And it's this one right here. We have these two lines, y equals 2/5 x plus 3, and y is equal to 2/5 x minus 2. These are both in slope-intercept form, and so they're really easy to graph. The top one has, of course, a y-intercept of 3 and a slope of 2/5. So to graph that, we can just put a point here at the y-intercept of 3, and then follow your rise and your run. Rise is 2, the run is 5, over to a second point, and we connect the dots, and there's our line, y equals 2/5 x plus 3. For the second one, we have a y-intercept of -2 and a slope of 2/5. So there's our y-intercept of -2. We follow our rise of 2 and our run of 5 over to a second point, connect the dots, and there is our second line. And what we should see here pretty simply is that these two lines are parallel. They are never going to intersect. And so this should be somewhat intuitive for you in that with parallel lines, they have the same slope but different y-intercepts. Of course, if they had the same slope and the same y-intercept, then they would be the same line. And so a line is not parallel to itself, it is itself. Parallel meaning it doesn't intersect, but of course a line intersects with itself in all of the points on the line. So this one should be fairly obvious here. Now for perpendicular lines, let's look at an arbitrary line here. I don't know what the y-intercept is, I don't care. We could count off the rise and the run. I'm kind of putting these in arbitrarily for a reason. Here we see that with the slope triangle, we have a rise of A and a run of B. So the slope of this line is going to be the rise A over the run B. Now, perpendicular lines, well, of course, they form 90-degree angles with each other. So what we might do is take this slope triangle here and rotate it 90 degrees. And it really doesn't matter which point we want to rotate it around. I'll rotate it around this one right here. And let's see what happens. So when we rotate this thing 90 degrees, it's nice because we have these horizontal and vertical lines in the triangle to mess with. So we'll take this line and rotate it 90 degrees, and it's going to become right there. This other line, when we rotate it 90 degrees, it's going to become a vertical line. Right like that. So now we've got a new slope triangle, and we can just connect the dots again here. And just be very careful to go through both points nicely. And of course, since we rotated the thing 90 degrees, we have two perpendicular lines. But the important thing here is that notice what happened. This rise of A turned into this horizontal line. It's now turning into a run, also of A. Now this run of B became this vertical line segment here. But now if we're looking at this as a rise and run, this rise became a run. This run now became a rise, but it's now not a rise of B, it's now going downward, so this is a rise of negative B. Right? Going to the right as a run is positive, going down as a rise is negative. So the slope of this new line is equal to the rise of negative B over the run of a positive A. So the slope of the old line was A over B. The slope of our new perpendicular line is negative B over A. And that's going to work with all perpendicular lines. So that's the whole idea here, is that the slopes of perpendicular lines are what we call opposite reciprocals. Notice it's opposite. This one would be positive, this one would be negative. Or if we're going from this line to the other one, this one would be negative, this one would be positive. Right? No big deal. But also, what was the rise becomes the run. What was the run now becomes the rise, with, of course, the negative. So we take the fraction, we flip it over, and we also make it negative. That's why I call them opposite reciprocals. They're opposite signs of each other, and they're also, if we forget about the signs, they're reciprocals of each other. Okay? And that's pretty much the big idea there. This one, slightly more difficult, but if you understand this picture, not a hard thing to remember. And so, I'm going to leave you with a couple of practice problems here. Just writing a couple of equations. Oops, it's tilted a bit. No big deal. So we want to write an equation for a line that's parallel to this one that goes through this point. So we write it in point slope form because that's really easy. And a line that's perpendicular to this particular line that happens to pass through this point. Now, after you write the equations, you can check your answers. Just use any graphing utility you want. Graph this line and the line that you just wrote the equation for, graph them, see if they're parallel. Graph this line and graph the equation that you wrote and see if they're perpendicular. One thing to be careful of, though. Let's just look at an example for checking these things, especially for the perpendicular ones. So let's put in a couple of perpendicular lines just to see what happens. Let's suppose we go with y is equal to 5/7 x plus 2, and a perpendicular line will have a slope of the opposite reciprocal of 5/7, which would be negative 7/5. And what the heck, let's go -1. Now if we graph these equations, there's the first line, and there's the second one. Now if we look really close, actually these two lines don't really look like they're perpendicular to each other. Well, that's because the screen on your calculator is a little bit skewed. It's more stretched out horizontally than it is vertically. So to fix that, what we can do is there's a nice little function here. If we hit the button zoom, we go down here on number 5, it says z square, which means it's going to reduce that skewedness, or it's going to eliminate it completely. So now we just hit enter. Now in our zoom square window, wouldn't you know it? Oh yes, these lines most definitely do look perpendicular. And so you can check yourselves with your calculator or your online utility, whatever you have available to you. So get to it. Write these two equations and check to make sure that you did them correctly. Okay? I'll see you in class.